Okay, so I'm recording it now.
Hello, Senik.
Yeah.
I think it is being recorded now. Okay, thank you.
All right. So we use printed circuit boards to provide both electrical connections between components and then give them a very strong mechanical support. For example, your laptop is on a printed circuit board, and that's the reason you can carry it around, put it in your bag, etc. The printed circuit board is made with a material that is non-conductive. That is, it is an insulator. And then they simply laminate the copper on one side or both sides or in between the various layers. All right. Now, there are some prerequisites for you to take this seminar. The first one is for you to download Autodesk Eagle. So whilst I'm doing the presentation, you can be able to download it and then install it in the background. Now, these are two images of printed circuit boards. I hope you've seen something like this before. Who hasn't seen something like this before? All right, so this is another one. This is a 3D model of a printed circuit board. This was generated using a software called KiCad. Let's now go on to learn about the different types of printed circuit boards, and then I'll take time to explain what each and every one of them can be used for. The first one is the single layer boards. The single layer boards are normally found in low cost electronic devices like radios, and then those cheap toys we normally have from China. The double layer boards are used sometimes in computers and then some of the high end electronic products. And then we have the multi-layer boards. You can have like 6-layer board, 8-layer board. You can have all the way up to 16 layers. And those are used for high-end space products, mobile phones, etc. We also have the flexible printed circuit boards. The flexible ones are used whenever you want to make a printed circuit board between two objects that can be moving, that has to be moving. Example, if you want to make a circuit between your door and then the opener, and then the door is going to be hinged, you have to do it on a printed circuit board. Another typical example is the flip phone that used to be available back in the days. There was a printed circuit board between the top that you can flip and then the bottom. And then we also have two types of printed circuit boards when it comes to whether there is a hole going through them or not. So we have the through hole PCB boards and we have the surface mount PCB boards. So if you take this, for example, you see that there are holes that are drilled on it.
Please, Senik, there's a request for the link to download the Autodesk Eagle. And someone is also asking if they can use Proteus.
You can use Proteus, but I will need to teach you differently if you are a beginner. But I have posted the link. Daniel, can you share it again? I've posted it again. So
Okay,
Daniel,
sir.
please keep the link and then share it to your colleagues. Okay. So you can see that this one is a board that all the components are mounted on one side, and you don't see holes drilled for component legs to go through, except these holes that are called vias. I will explain what they do shortly. So let's now talk into detail about the single layer boards. So once again, they are used very widely on the market, and then they are very easy to prototype at home. So it consists of 4 different layers. The first layer is a silk screen. The silk screen is usually the printing that they do onto it. For example, when you look on this board, okay, I don't see a silk screen yet, but I will show you the silk screen when I see some shortly. But normally you see they write things with white ink on those boards. That is the silk screen. Then the next one is some It's called a solder mask. The solder mask is just a paint that they put on top of the copper. And then the third item is the copper. The copper is the one that does the conduction between the various legs of the components. And then the last one is the PCB material. The PCB material is the insulator. All right. I'll talk a little more about the PCB material soon. Then we have the double layer board. The double layer board is also very used widely, and it comprises of the PCB material in the middle and then a repeat of what we have seen on the single-sided board. That is, the copper material is on both sides of the board. And then we use the solder mask, which is a paint that when you are soldering the board, it will prevent you from connecting other components to each other. And then we have the paint, which is usually white on both sides, that they use to put the names of the components on the board for easy soldering. So normally, if you want to connect from, let's say, this layer of the board to the other layer of the board, we use something we call the via. The via is just a hole that has copper through it, and it can connect from one layer of the board to the other. I'll show you that shortly. So the next one is the multi-layer PCBs. With the multi-layer PCBs, you can see that we have, for example, here we have 3 layers of the PCB material, which is marked core over here. And then the copper is the yellow material. So you see the copper comes to this layer, and then it goes to this via, and then there are components in between the various layers, and then there's another via connecting this layer to the bottom of this layer. All right. Most mobile phones are multi-layer PCBs. That's the reason you don't see a lot of connections on the board. Now, this one is very difficult to work with at home. So you need to actually forget about this one when you are prototyping at home. And this is used for military applications, space applications, or situations where you need to have you have a very small space and you want to put as much of circuitry over there. An example is the endoscope. The surgeons use that for surgical operations. We also have I forgot. Now this is the flexible PCB. So you can see this as screen, and then you use the flexible PCB in between the screen and another printed circuit board, so that the screen can be able to move up and down, and there will be no need to fix this permanently on the surface that you want to put it on. So these flexible boards can be either double layered or single layered. Another commonly used PCB is the aluminum backed PCB. With the aluminum backed PCB, it's used whenever you want to take heat away. Example, when you take the lights we have in our homes, there is this LED lights that are very common of late. They are used, when you open them, they look something like this. The aluminum PCB is used to back the LEDs so that when the LEDs are producing heat, the aluminum will conduct some of the heat away. So this is an example of a true hole PCB. You can see that there is a hole for the legs of the components to go through to the other side so that they can be soldered. And then this is an example of a surface mount PCB. You can see clearly that the components are just mounted on one side, and then the holes you see are vias. They are used to connect from the bottom of the board to the top of the board. So normally when you are working with these boards, we use liquid lead to solder them. You just use the liquid lead, you pour it on some of the legs, and they use hot air to blow it, and then the components will just solder by themselves. I'll find a link of the process and then share it with you in the chat box. So this is another slide. This one details the various components of the PCB. So when you take a sample PCB like this one, the component is this one over here, and then it goes through the true hole over here, and then you normally solder this side, and then you solder that side. So this is a typical double layered board. And then the material, PCB material is in between the top layer and then the down layer. And then there is this via passing through this point to that point. Okay. This is a sample of the board once more. Let's now talk about the materials they use for making printed circuit boards. The most common one is called FR4, and it's made with fiberglass.
So there's a question.
All right. I'm checking the question now.
The question is it possible to have a flexible PCB incorporated with a true hole PCB?
Yes, please. Very possible. We do that a lot. I'll finish some of the slides shortly and then I'll give you the chance to ask questions. But you can feel free to type them. When I see them, I'll answer them. So the less commonly used materials are FR1 and then FR2. The FR1, normally when you open very old radios, they look brown. And then they mount the components on one side and then the bottom is very green. That is FR1 or FR2. There are other materials called CEM1 and then CEM3. It all depends on the application that you want to use them for. Two other types of materials used are the polyamide and then the prepreg boards. You can Google those materials if you are interested in them. Let's now go to what kind of software you can use to make printed circuit boards. So there are a whole lot of software that you can use for making printed circuit board. My favorite one is Autodesk Eagle, but I am able to use all the various software you can see over here easily. Autodesk Eagle is now a paid software, but you can get it for free if you are a student at Ashesi. And then KiCad is free and it is open source. Proteus is also a paid software, but we have it for you to use in Ashesi. We have about 200 licenses for you guys. And then we have Altium. So between Altium and Autodesk Eagle, most people prefer to use them. Most people prefer to use Altium and then Autodesk Eagle. And Altium is kind of like considered the industry standard for printed circuit boards. And then we also have the multi-sim, and we have the Easy EDA. The Easy EDA is an online one, and you can easily just Google it and you can start designing your printed circuit boards right there. If something is not clear in this presentation, you can just Google it, or you can ask me, and then I'll be able to explain it to you. Any questions so far? If you don't have any questions, I would like to ask a few questions myself. So I'll just mention random names, and then I'll ask you a question. Dominic Abuaji, why do you think I would like to use a multi-layer PCB?
Hello.
Hi, I can hear you very well.
Please, the question again.
Why do you think I want to use a multi-layer PCB?
Okay, so I think if maybe you have a lot of components and then you want to make it such that it will be like it will not be so bulky on the PCB, then you can use the multi-layer.
All right, fantastic. That's a good answer. Felicity. Double layered and single layered, which one do you think is more widely used? Hi, Felicity, are you there?
She has typed her response, that double layer.
Okay, she has typed her response. All right.
Yes.
Thank you. I'll check it out. Who is DZ? Yeah, DZ.
Marshall.
It's Marshall.
Yes.
Can you give me one application of flexible printed circuit board?
Okay, let me think for a second. I'll bring that to you.
Let's be fast. Or you're also typing? All right, so let's move on. But I'll get back to you, DZ. Now, the most important thing you need to be to know to be able to
Felicity has responded for him, and he said flip phone.
flip phone. Hi, Felicity. I want to hear your voice. I miss you so much.
Hi, Nicholas.
Wow, is that you?
Yes, please.
All right. Enjoy Lekki. Okay, so to become a very good professional PCB designer, there is only one single thing you need to be very good with, and that thing is called packages or footprints. All right. If you know your footprints, you can design anything you want to design. Okay. So I'll take you through what I mean by packages. So when you see electronic components, they all exist in what? Different formats. Okay. You see electronic components, some looking like this, some looking like that, some looking like this. Haven't you seen some of these things before?
I have.
Correct. So all this, they are all called what? Packages. So they all contain the same silicon, but the way they present the component to you is the format in which it will look, and that is called packages. And all these packages have different names. Okay. One common mistake a lot of students make is when they see something looking like this one, the one with my cursor on it, they say it is a transistor. Some people say it's a voltage regulator, but not everything that looks like this is a transistor or a voltage regulator. All that this thing represents is what? A package called TO220. So anything that can have 3 legs can be packed into this. Is that clear? So what you are seeing here is like choosing a bag for a journey. Okay. You can have a bag that has what? Tires under it. You can have a bag that you can strap on your back. You can have a bag that you can strap in front of you, a bag that you carry on your head, etc. Is that clear? So we package, for example, CPUs in this format. It's called the PGA package. And then we also package another component. It's called the BIOS. They prefer to package them in this format called PLCC. And then we have this package I spoke about it called what? TO220. And then we have this one called what? PQFP, plastic quad flat pack. Okay. Now we have the quad flat pack in different formats. We have one with 32 legs, one with 100 legs like this one. All right. So all that you have to do to become a good PCB designer is to maybe Google electronic footprints and know the footprints and then the reason why they are widely used for some reasons. Okay. When you take, for example, audio amplifiers, they use this package a lot for them. The reason they do that is because you can fix a metal at the back and the metal will take the heat away from the IC. All these ICs with aluminum at the back are all for conducting heat. And that is the reason why this package is also good for them. So there are over 100 and something packages and more. You can Google them, get to know all of them, and then learn how to work with them. Okay. So this is another slide, and then it still talks about what? Packages. The point I'm trying to drive home is the most important thing you need to know is what? Packages. Now let's talk about today's project. Please, have you watched the video that I shared earlier on this project with this block diagram over here? If you have not watched, you can say it in the chat box.
No, please, I haven't watched.
Okay, I'll just briefly play the ending of the video where I explain the task for you to. And who is here who hasn't subscribed to the YouTube channel I've been sharing? Okay. So the video is entitled Recommendations for Capstone Projects at Ashesi. I'm about to play it. And then send on the contactors as per the must be able to reach your project. Now, let me now talk about the sample project that I will be doing to illustrate how to go about your final year. My client is a solar installation company located at Hashi in Accra. And the image below is the image of their electrical room. And then they have two contactors here, contactor A and then contactor B. Can you all watch the video? Now they have two sources of power. The first one is the grid power. The second one is the solar power. And my goal is to be able to prioritize the solar over the grid whenever both solar and the grid are available. So I have been tasked to build a controller for these contactors and then turn on the contactors as per the preferences of my customer. Now, I will be using 3 different approaches to build this project. The first one, I'll use a bare bone microcontroller. That's ATmega 328 or any microcontroller within its family. So the ATmega 328P is a microcontroller belonging to the Atmel family. I will then go with ARM Cortex and then build the same project with the ARM Cortex. And then after that, I'll be using ESP32 to design the same project for you to see. So when I use the ESP32 to build the same project, it becomes an IoT device. Now, this is an overview of the project that I'll be using to illustrate how to go about your final year project. At the heart of it is this microcontroller. And as I said earlier, I'll be using either ATmega 328 or ESP32 or either MKL25Z or STM32. The project has 4 LED indicators. The first one is the solar source LED. This one indicates that solar power is available. The second one is the grid source LED, and this indicates that the grid source is also available. The third one is to tell us whether the system is in manual mode or automatic mode. And then the next one is the automatic mode, which is also an LED to indicate that it is in what? Automatic mode. There will be 2 push buttons. The first one is to put the system into automatic mode, and the second one is to put our system into manual mode. Now, we are going to be having 2 relays. The first relay, which is the grid relay, will control the grid contactor, and then the second one, which is the solar relay, will control the solar contactor. Now, we are going to take the input of the grid using this into the microcontroller using this block, and then we are going to take the solar supply input into the microcontroller using this block. And then the yellow box here will be the power supply for everything on this block diagram. I will then have a debug interface and as well as an in-system programming interface for programming the microcontroller whilst it is on site. All right. All right, I believe you've all understood the block diagram of what we are coming to design. Who has not understood it? Anyone who has not understood the block diagram? So there is a company called SunPower Innovations in Hachu, and they have two sources of power, the grid supply and then the solar supply. And they want me to choose the solar over the grid whenever both are available, okay? So I've done a simulation of the project, and I've also done explanation of the block diagram, all are on YouTube, okay? So you can refer to the YouTube videos and then learn more about those projects. And then for today, we are just coming to design the printed circuit board for it. So in the video, I mentioned on YouTube that all our chassis projects should look very elegant and beautiful. So what we are coming to design will be inside a box like this, all right? You can go to this website, SZOMK, and then they have different boxes over there. And then you can choose the one that you like, and then you can design with it. So let's now get started with Autodesk Eagle. Now I want to pause the Zoom, and then you can use the same link to enter the meeting again. I just realized they have limited my account. All right, so I'll stop the meeting, just use the same link to come back into the meeting again.